1, we talk about solving linear inequalities in one variable. Notice that all of these are inequalities. The inequality sign less than, equal to, etc.
Tip on to the smaller quantity and the mouth open to the bigger quantity. So you can read this 2 is less than 3, or you can read this as 3 is greater than 2. Okay. So the first one here is 2. Okay. 2 is less than 3. So it is 2. What about the second one? 3 is less than or equal to 3. Is that true or not?
True.
2. Yes, because it says 3 is less than or equal to 3. So because they are equal, so it is true. Okay, so this is also true. Okay, so 2 over here. 5 is greater than or equal to 2. That's also true because 5 is greater than 2. Okay, so all of these are true. Now the next one we're going to talk about will be interval. Okay, when I try to represent those numbers that are greater than 3, so I will shade it the right side of 3, and I use a parenthesis over here. That means the 3 is not included. So x will be on the right side of this 3, but not including 3. So x is greater than 3. Okay. Now notice that parenthesis here means you don't include this endpoint. So it's the same as you have this open gap, and then now you shaded the right side of this 3. So on the number line, you will shade it the right side of 3, but not including the 3. So these two both represent that the 3 are not included. Now, another way to represent all those numbers that are greater than 3 is use the set builder notation. So the set notation is a pair of curly braces like this. And then inside, you put down x, but not all x. Okay, only those x that are greater than 3 will be there. So you put down x greater than 3 over here. So this bar over here, you can read this as such that. So this stands for all those x such that x is greater than 3. Basically represent those numbers that are greater than 3 on the right side of 3. So parenthesis here means that the endpoint are not included. Now, if you represent this set here using the interval notation, you go from left to right. Okay, so I'll put down 3 over here. And because the 3 is not included, so you have a parenthesis over here, and then comma, and then you keep on going to the right side. Well, without n, right? Because this one keep on going without n. Okay, so it's going to infinity. So we call that going to infinity. So infinity is this side. So from 3 to infinity, not including 3, and also not including infinity, because infinity is not a real number. It does indicate that the number keep on going, increasing and increasing without n. So we can never reach infinity. Okay? It's not like Toy Story to infinity and beyond. Right? So we can never reach infinity. So that's why I have a parenthesis over here. So parenthesis after the infinity. So this is called the interval notation for this. Now looking at this. Okay, this is a graph. So over here, indicating all numbers that are greater than or equal to 2. You see the solid dot here, or the bracket here, means the 2 here is included. So all those numbers on the right side of 2 or equal to 2, so that, now how can we represent that set over here? So we use a set notation, okay? So that will be a pair of curly braces, and then we put down x, but not all x. X here has to be greater than or equal to 2, okay? Because they're on this side of 2 and also including the 2, okay? Using interval notation, then you will go from left to right. So the left here will be bracket 2, okay, comma, and then go all the way to infinity, okay? So we can never reach infinity, so we always use parentheses for that, after that, okay? Question? Any question?
Yes.
Are you guys able to see?
Yeah, we can see.
Okay, that's good. Okay, now it's the second one. This one here represents all those numbers that are between 2 and 3, not including 2, including 3. So it's like an open gap here and solid dot here, okay? So 2 is not included, but 3 is included. To represent this in a set, so you put down all x such that x is strictly greater than 2, less than or equal to 3. So when it's included, there's an equal sign here, and it's a bracket. When it's not included, So it's a parenthesis here, and this is strictly greater than. Are you good? Now go back to, actually, I want to bring your attention to this. Some students put this as infinity to 3. This is not right. This is not right because it has to go from small to big, okay? Left to right. Okay, infinity indicate number keep on increasing. So the 3 is small. No, it keep on increasing, so you cannot change the order. So 3 first and then infinity after. Okay, so we get to this. Now, if I try to represent this in into notation, so basically it's just copy this. So that will be parenthesis and then 2, comma 3, and then bracket over here. Now what about this? So if the whole number line here is shaded, so how do you represent this all real number? What will be the set notation for that? The set notation for all real number will be this capital R with double bar. This stands for the set of all real number. And if you write that in into notation, what would that be? So if you use into notation, that will be, now on the left here, if the number keep on decreasing without end, so we call that negative infinity. Again, we cannot reach it, so use a parenthesis over here. And then all the way to the right, the number keep on going without end, so infinity, we cannot reach it, so after infinity you put parenthesis. Okay, now when we solve inequality, kind of similar as solving equation, we can add both sides with the same number or subtract both sides with the same number. We can multiply both sides with the same number. When you multiply both sides by the positive number, then the inequality side doesn't switch. Because think about if you double this side and you double this side, the bigger side is still bigger, right? So think about this like not like a scale that's not balanced. So one side is heavier, the other side is lighter. And if you double the heavier side, double the lighter side, the heavier side is still heavier, right? And similarly, divide both sides by the same positive quantity. So if you chop it up and you only take 1/3, and chop it up to only take 1/3, then the bigger side is still bigger. So the inequality side is not going to switch, okay, when you do this. However, when you multiply both sides by the same negative number, so say I start with 2 less than 4. If I multiply both sides by -1, then I will end up with -2 here, -4 here. So I have 2 and 4 here. Multiplied by -1, I will go to the other side, the number 9. So I will get -2 here, and I will get -4 here. Now what do you see? You see this bigger number over here? This is bigger, right? Before it was bigger. When you multiply by -1, it actually turned out to be the smaller one. Comparing to this -2, this is smaller, okay? So when you multiply by a negative quantity, you will end up at the other side of this number 9. The bigger number becomes the smaller number. So the inequality side here had to switch. So -2 is greater than -4, right? Okay, -2 is greater than -4. Okay, so multiply both sides by the same negative quantity, you need to switch this inequality side. So switch. Okay. Similarly, if I divide both sides by the same negative quantity, so divide by -2, divide by -2. Divide by -2 here, I will end up with -1. Divide by -2 here, I end up with -2. -1 is greater than -2, right? So you see that the inequality side here also switch. So tip over here was point to the other side. When you divide both sides by the same negative quantity, then you need to switch this inequality side. So I make a weak mark over here. So when you multiply or divide both sides of this inequality by the same negative quantity, see, by the same negative number or negative quantity, then the inequality side must be switched. So the tip is going to point the other way. Okay, before it point to this left side here, now it's going to point to the right side over here. Do you guys understand now?
Yes.
Okay, that's good. Now let's try to do use this to solve this first one. Okay, negative 4x less than negative 16. Okay, now to solve for x, just like solve an equation, we're going to divide both sides by negative 4. So on this side, I end up with x. On the other side, I end up with positive 4. What side should I have over here? Does the inequality side here switch or not?
Yep.
No.
Yes, it switch. Okay, so it had to switch inequality side. Okay, the reason for that is you are dividing both sides by the same negative quantity. I'm dividing both sides by negative 4. So you have to switch inequality sign right here, right? Now some people write it this way. So negative 4x. Some people write it this way. And then they put down over negative 4 over negative 4. And then the next step they put down x is greater than positive 4. Now, something's wrong over here. What's wrong over here? This is wrong. Why? This is the action step. This is the action. This is the step you take the action. You divide both sides by negative 4. So if you don't switch your inequality sign over here, then what you're seeing over here is this side over here is equivalent to x. This side over here is equivalent to 4. And now you're saying x is less than 4. And then all of a sudden, the next step, you're saying x is greater than 4. So you are contradicting yourself. So if you have this and then you have this, you're contradicting yourself. Because at this step, you're saying x is less than 4. And then at the next step, you're saying x is greater than 4. So you're contradicting yourself. You shouldn't do this. Okay. So what's the correct way to do this? The correct way to do this is once you put down over negative 4, divide by negative 4 on both sides, you have to erase this and switch the inequality sign right here at this step. Okay. So you will erase it and you will switch the inequality sign right there. You understand now? Okay, so you will switch inequality sign at the action step. Whenever you put down divide by negative 4, that's the action step. And then this one here, you just rewriting. X is greater than 4. Okay, so erase this and switch here. Okay, now let's try the next one. This one over here, we're solving this inequality. So first we will combine line chain. So these two are line chain. Combine them, I will get negative 8x minus 9 less than or equal to, and over here you combine line chain. So you have 4x plus 15. Now I want to have the x on the left side. Suppose that's what you want, okay? Then I will need to get rid of this 4x on the right side. So to do that, I will subtract 4x from both sides. Okay. Just like our equation, okay? And I will end up with negative 12x over here. And notice that this cancels. Now, when you add and subtract, the inequality sign is not going to switch, okay? When you add or subtract. Now, I have the x on the left side. I would like to have the number on the other side of this inequality. So I don't want this number to stay here. So undo that. We'll add 9 to both sides. So I will end up with, on this side, I will end up with 24. Now notice the add and subtract. Add or subtract doesn't change the inequality sign. So it's going to stay the same. Okay. Now when you get to this step, what are you going to do? To isolate x, we will undo this multiplication with negative 12. So what do we do over here? Divide, right? Okay, so now I'm going to divide both sides by negative 12. Divide both sides by negative 12. Once I put down divide by negative 12 over here, what should I do with this? I need to erase it and switch right here. Okay, so I will erase this and I'm going to switch inequality sign right at this step. Don't wait until later because this is the step that you take the action. Okay, so you switch over here. Now the next step, you would just rewrite this. So this is x and greater than equal to, and this is negative 2. So x is greater than or equal to negative 2. Do you guys get it? Okay. Just pay attention to make sure to switch your inequality sign at the step that you divide both sides by the same negative quantity. Okay. Now, how do you graph this? Okay. Suppose they ask you to graph this. To graph this, you draw the number 9. And then you locate this negative 2. X is greater than or equal to negative 2. So it will be on the left side or the right side negative 2. It's going to be on the right side. And because there's an equal sign over here, you see there's an equal sign. So the 2 is included. So we make this bracket. So we will shade this way. Okay, that's a graph. And if you put that put the solution set in interval notation, then that will correspond to this interval. So start with negative 2. So bracket negative 2, comma, all the way to infinity. So infinity, parenthesis after that. Okay. You can understand now?
Yes.
Okay, that's good. Now the next one. To solve this one over here, let's try the different way to do this. Okay. One way to do that is to get rid of the denominator 15 over here by multiply both sides by 15. So we have negative 7 times 15. Now times 15 is not going to switch the inequality sign because 15 is a positive quantity, right? So 15 times 16 over 15a times 1. Okay. So multiply both sides by 15. Multiply by positive quantity on both sides. The inequality sign is not going to switch. Only when you multiply by negative, right? Then you switch. So over here, I got negative 105. And now over here, this cancel, right? So give you 16a plus 15. And then you subtract 15 on both sides. You end up with negative 120 on this side, greater than 16a. Now what do I do? Divide both sides by
16.
Okay. Divide by positive quantity is not going to switch this inequality sign, so stay the same. Okay. So a here is less than, and this should be negative 7.5. Okay, or you can put negative 7.5 or negative 15 over 2. Okay. The convention is we want the variable we solve on the left side. So another way to write this is a is less than negative 7.5. Okay. So this is preferred. Okay. Okay. Another way to solve this inequality is this. So we have this inequality over here. We can isolate this a term because that's we want to solve for a. So if I want to isolate this, I will subtract 1 on both sides. So subtract 1 on both sides. I I will end up with negative 8 on this side. So I end up with negative here and 16 over 15 times 8 on that side. Okay. And now we can solve for A by trying to make the coefficient here become 1. So what number times this will give me 1? So I want to have a coefficient to be 1. So think about what can I multiply here?
15 over 16.
Yeah, you got it. 15 over 16, which is the reciprocal, right? So which is the reciprocal of 16 over 15. So when you multiply this fraction by its reciprocal, the product will equal to 1. Okay, so times the reciprocal of this. Now I would like to, I will also need to multiply the other side by 15 over 16. So I have times 15 over 16 on this side. And the inequality side is not going to switch because 15 over 16 is a positive quantity times the positive quantity on both sides. Inequality side will not be switched. Okay. Now on this side here, I will have A, and this side here I have, over here you reduce it, divide by 8, divide by 8. So you have negative 15 over 2, or you can put down negative 7.5, either way. But this is also correct. Okay, this is correct also. The convention is you put the, so the convention over here is you put the variable that you're trying to solve on the left side. So you put it down as A is less than negative 15 over 2. As long as you keep the tip point to the same side, then these two are equivalent. See the tip point to A here? See the tip here also point to A? So these two are equivalent. A is less than negative 15 over 2. Okay. Now to graph this, okay, let's look at the graph. For your homework, you graph this. So this is the number 9. You locate negative 7.5. And because this is strictly less than, negative 7.5 is not included. And those number is less than that, so it will be on the left side. And you have parenthesis over here because this is strictly less than, so negative 7.5 is not included. So parenthesis over here. Another way to put that is you can put negative 15 over 2, okay, this one or this one. Now, if you put that in interval notation, then the interval will be, what would the interval be? Anyone?
Infinity.
Negative infinity, parenthesis negative infinity, because the left side here, the number is smaller and smaller, right? So it's negative infinity, parenthesis negative infinity, comma, and then what?
Negative 7.5.
Negative 7.5. After that, you will have parenthesis. Yeah, parenthesis right here. Okay. Okay, now the next one. This one here, we like to get rid of the denominator by multiply both sides by the LCD, which is what? What's the LCD of this?
15.
15, yes. So we're going to times 15 on both sides. Now, notice that when you multiply by positive quantity, then there's no switch on the inequality side. Okay. Now, after that, you reduce it first. 15 over 3 is 5. 2 times 5 make 10. 15 over 5 is 3. 3 times 4 make 12. Now you go ahead and distribute and go ahead and solve for x. Can you guys continue with this? Tell me what you get. Solve this. What do you get? Okay, let's do it together then, okay? So after you distribute, you got this. Now you will say, let's have the x on the left side. Suppose you want that way. So we subtract 12x on both sides. You can just do it manually. You don't need to write this down, okay? So you end up with negative 2x here, okay? And now you want the number on the other side, so you will undo this. So we subtract 20 on both sides. So you end up with negative 56 over here. Now what do I do?
Divide by -2.
Yes. So divide by -2. Okay, so divide by -2 on both sides. Then do I switch inequality side here?
Yeah.
Yes. So you switch. Okay, go this way. So you switch. Okay. Now this is x less than 28. So x is less than 28. So the graph of this will be, you will shave the left side of 28 because those x are less than 28. So on the left side 28. And because there's no equal sign over here, so you have parentheses over here. The into notation for this solution set will be parentheses, negative infinity, comma, and then 28, and then parentheses afterward. Parentheses means you don't include this endpoint. Question? All right, so let's look down over here. This one over here, how do we solve this? Right, solve for x here. I will have this divide both sides by -2. And you need to switch the inequality sign right here, right? You switch. So you get x is greater than -4. Now what about this one? You divide both sides by -5. Do you switch inequality sign here?
Yes.
Yes, you do. Okay, so you switch over here because you're dividing by the same negative quantity on both sides. So x is less than 2. I didn't switch right here. Did you see what I did? I say switch, but I didn't. Okay. So here is less than. So the tip point this way now. Okay. So x here, the 2 here, x is less than 2. Okay. You see it. Okay. The next one over here. This one over here, we want to get rid of the denominator here by multiply both sides by the LCD. What's the LCD here?
5.
You say 5, but it would be better if you say it's -5.
-5. See?
Yeah. So -5. Okay. So we're going to times both sides by -5. What happened to this inequality side? Switch or not?
Yes.
You say yes. Okay. So yes, it's switch. Okay. So tip point to the other side. Okay. So we need to switch. Okay. Then the -5 here cancel. Okay. So that will end up with 3a minus 4. And this side is 3a plus 15. Now notice that this step here, you can do it mentally. Say multiply both sides by -5. You will get 3a minus 4 on this side, 3a plus 15 on the other side. So you can go straight from here to here. Okay. Now what do I do here? I would like to subtract 3a on both sides. Then we'll end up with -4, and this is 15. Is this true or not? Is -4 less than 15?
It's true.
Yeah, that's true. Okay. So this is true. And no matter what this a is equal to, okay? So this is always true. So this inequality come from this one. So this is always true. That means this one here is always true. No matter what this a is equal to, that will always be true. Okay? Because that is equivalent to this. Okay? So true, no matter what this a is equal to. So what will be the solution set? So what kind of number I can put into a here to make this one true?
Any number?
Any number. Yes, we just said that this is true all the time, no matter what a is equal to. So a could be any number. So all the number on the number line will be included. Okay, so will be all real number. So this is set for all real number, the capital R with double bar. Okay, now the graph of it is going to be the whole number 9. So you just graph the whole number 9. Okay. Right. So the solution set for that will be all real number, and the graph will be the whole number 9. Okay. Now let's recall that for equation. If we end up with, so I'm going to compare this with the equation. So for equation, if we have something that's always true, then the answer will be what? Do you guys remember? All real number, right? Okay. And if we end up with an equation that's false, that's something we call contradiction, then the answer here will be no solution. And then we put down the solution set to be the empty set. All right, so this one here is always true. See, we end up this inequality that's always true, and the solution set is always number. Okay. Oh, okay, try this one. Now this one over here, we first distribute over here. So we get 1 minus 2a greater equal to, here I have 2 minus 2a when I distribute. And we subtract 2, when we add 2a to both sides, then this 2 will cancel. Okay, so when you add 2a to both sides, okay, then I'm going to end up with 1 on this side, the other side is 2. Is 1 greater than or equal to 2? True or false?
False.
False. So I end up with a false inequality. Just like when you end up with a false equation, the answer will be no solution, or you can write down the solution set will be the empty set. Okay, so the answer here will be no solution, or you write down the solution set to be empty set. You can understand now? Okay, good. Okay, now the next one. This one here happened in homework, so I'm going to give you some hint on this one. Let's go over this together. So suppose a student score this on the first 3 tests, and then the final count as twice the test. So double. So the final weighted twice as final count as 2 tests. Okay, and the student have taken all this except the final. So this class, for that class, that particular class only have test and final. So we want to know what to score for the student. The student want to know what to score in final to get a B in class, which means we have to have an average of 80 or above in class. So how can we find out what to score in final in order to get a B in class? Suppose the student score like this in the first 3 tests. Now remember, for a word problem, we have the 4 step, LESS, right? For this, I also have 4 steps, okay? The first step with L, that declare the variable. So we're going to let X be. Let X be whatever they're looking for. They're looking for the score in the final. So let X be the score in the final. The second part, well, before was equation, right? E. However, this one here will be inequality. Okay, that's I. So in order to get an A, the student had to average 80 or above. Okay, so you need to have the average. 80 or above means it is greater than or equal to 80. Right? What do you mean 80 and above? So 80 is included and then greater than. Okay, so it's greater than or equal to 80. Now, how do you find this average for the student? Well, for this class, they have only a test and final, and this count as twice. So to find average, you add them up and divide by the number of tests, right? So I will have 70 plus Okay, 80 plus 90. So I add this, and this. I also add this. So plus x. But because the final here counted twice the test, so I need to add this one more time. Okay, so you can add 2x. So x and x. Okay. Now I add them up and I will divide by the number of tests. Divide by what? What number? Any idea?
3.
Not 3. So you have 1, 2, 3, and this count as twice, right? So 1, 2, 3, 4, 5. 5 tests. This one count as 2 tests. So 1, 2, 3, and then adding 2. So it will be 5. So divide by 5. Okay, that's the average. Now it is greater than or equal to 80. Now we set up this inequality. That's the second step. Okay. Now we're going to go to the next step. We're going to solve it. Okay. The first step is to let. Second step here is inequality. The next step is to solve it. Okay. To solve this, we multiply both sides by 5. Actually, we should simplify this numerator here first. Okay. So add this up. 70 plus 80 plus 90 is 240. So 240 plus 2x. And then divide by 5. Is greater than or equal to 80. To solve this, we multiply both sides by 5. So we get 240 plus 2x greater or equal to 400. Right? Okay. So times 5 on both sides. Okay. Now, to solve this, you will subtract 240 on both sides. You get 2x on this side. 400 subtract 240 is 160. Now you divide both sides by 2. So x is greater than or equal to what?
80.
80. Yeah, you got it. 80. Now we solve this. Right? Now we solve this. So x is greater than or equal to 80. So at the end, just like any other word problem, you write a complete sentence to answer the question. Okay. So you will write it down. So write a complete sentence to answer the question. So the sentence could be like this. The student need to, oh, there's an S here. Okay. So the student needs to score 80 or above in final to get a B in class. Okay. And then you're done. Question? Okay.
No.
Okay, no? Okay. You had to, if you have background noise, then okay. Can you guys mute your background? Okay. Okay. Now, say in this class, okay, so a lot of students ask me, oh, what do I need to, before the final, they say, what do I need to score in the final in order to get an A in class? Okay, so let's try to think about a situation like that. Okay, so to get an A in this class, the weighted average has to be 90 and above. Okay, so the way for this, actually I changed the scale. Do you guys remember for us? Okay, let's change the scale. Okay, you guys see it, right? Do you guys remember what's the weight for each category? Anyone remember? For homework is how many percent? Class participation is actually 20% now. Okay, 20%. The final is 20%. The test over here, I think 15.
15%.
Huh?
15%.
Yeah, 15% now. 15%. And then the quiz will be also, is it 15%?
15.
And then for homework will be, let's see, I think
30.
30%. Okay. So 30% for homework, 15% for quizzes, 15% for tests, the final 20%, class participation 20%. Let's see if they add up to 100%. Yes, okay. All right, so this is the weight for each category. You see class participation is important, same way as the final, more than the test and quiz, okay. Now suppose the students go like this. For homework, the student have this 96 average for the homework. And for quizzes, the student get 90 for average, 90%. And the test get 88. And class participation, the student usually participate pretty well. And participation including attendance, okay? And also the posting in the discussion and also pronto. And also speak up in class or ask question in class. Okay, so that's how this class participation here works. Okay, so suppose the student has this score here and want to know what to score in the final in order to get an A in class. Okay, so let's find out. So what do we do here? So I'm going to let X be the score of the student in the final. Okay, and now because this is the weighted average, okay, then I'm going to multiply this with the weight of each category. So going to multiply over here, 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 and here. Okay, multiply over here. This is what's 30% of 96. Use your calculator. You're gonna get what? 28.8. Okay, so 28.8. And what about this? This is
13.5.
15. 13.5. Is that what you said?
Yes.
Okay. And what about this? Use your calculator.
13.2.
13.2. Right? Okay. Listen. I went out to bed and wait, this doesn't work. Okay, I will rely on you now. Okay. And then this one over here, it is 0.2 times x. Okay. So you write that, convert the percentage into decimal. So that will be 0.2 and then times x. And then this one over here will be 18. Yes. Now you're going to add them up. Okay. You sum them up. So this add this, add this, add this. Tell me what you get. Do you get 73.5?
Yes, 73.5.
73.5, and then you're adding
So
0.2x, right? And you want to get an A, right? So you want this to be greater than or equal to 90, because you need to have the average have to be 90 and above, right? Right here. So greater than or equal to 90. Okay. If you're a B, it will greater than or equal to 80. But if an A is greater than or equal to 90 here. Now to solve this, you will subtract this 73.5 on both sides, right? Then you're going to end up with 0.2x greater or equal to, let's see what I get. This is 716.5, right? Okay. So 16.5. And now you divide by 0.2. Okay. What do you get? Divide by 0.2.
82.5.
82.5. So divide by 0.2, that's 82.5. So the student just need to score 82.5 in the final in order to get an A in class. It's because the student has good score in the homework and then quizzes and also class participation. Even though the test is a little bit less than an A, but it's still okay because the homework here and really help. Okay. And then you can write a complete sentence. So the student will need to score 82.5 in the final in order to get an A in class. The student need to score 82.5 or above in final to get an A in class. Yeah, that's the end of the lesson. Okay, do you guys have questions? Can you enter in chat? I'm going to look it up after class. Yeah. Okay. It's the tallest one in Europe. Wow. This is really cool. Okay. Wow, thank you for sharing this. Okay. Well, very interesting. You guys all taught me some new things. Okay. I enjoy learning new things from you guys. So it's like in a movie. Okay. It's a movie name. It's called Madame Renee.